The overall goal of this procedure is to produce optical micro-resonators for laser devices, optical circuits, and chemical and biological optical sensors.
This method can help answer key questions in the functional polymer materials field, such as polymer optics, optoelectronics, and electronics. The main advantage of this simple and low energy consumption technique is that it uses functional polymers to fabricate optical resonators, which have both optical and electrical properties. Demonstrating the procedure will be Mr. Okada, Mr. Zakarias, and Mr. Oki, graduate students from my laboratory.
To begin the vapor diffusion method for this procedure, add 5 ml of methanol to a 50 ml vial. Next, dissolve 2 mg of conjugated polymers in 2 ml of chloroform in a 5 ml vial. Carefully place the 5 ml vial inside the 50 ml vial. After this, cap the 50 ml vial. Incubate at 25 degrees Celsius for 3 days to precipitate the polymer microspheres. To begin the mini emulsion method, dissolve 5 mg of conjugated polymers in 1 ml of chloroform. Then, dissolve 30 mg of SDS in 2 ml of deionized water. Add 100 microliters of the polymer mixture to the SDS solution. Using an ultra-high-speed homogenizer, stir for 2 minutes at 30,000 RPM. Allow the emulsion to rest for 1 day without the cap to evaporate the chloroform.